Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and very good morning. Today I will present to you about my research. The title of my research: Impact Properties of Basalt Glass Composite Filled with Granite Fine Powders as Filler with Industrial Polyester. My name is Muhammad Ashraf Muslim and another author is Aida Jumahat, Syarul Azam Abdullah, Muhammad Khalid Azrul and Raymond Siu Teng Loy. And I'm from School of Mechanical Engineering, College of Engineering, UITM Shah Alam Selangor. And my Muhammad Khalid is from Indonesia, University of Indonesia, and Raymond Siu Teng Loy is from Carbon Tech Global Sdn Bhd. This is my team member. My name is Muhammad Ashrafi. I'm Azrul, Prof. TS Dr. Aida, my supervisor, my co-supervisor, Prof. Madya Syarul Azam, Prof. Madya Khalid, and industrial collaborator is Raymond Siu Teng Loy. My project is one of the smart partnership with Carbon Tech Global in Sungai Rawang, and this is the MOU signed in 2020 between UITM and Carbon Tech Global. Carbon Tech Global is a company that produce composite and is also produce automotive parts, bumper accessories, rear front and side skirting, part based on fiberglass and post-slide delivery box. So my research is applied to application of this newly developed FRP composite be used as a truck body, as an alternative metal truck body. And the background of the research, nowadays natural fiber composite have raised great interest among material scientists and engineers. So because they are abundantly in around us, so we want to reducing the dependency to the synthetic fiber is the fiberglass. So the growing interest is the researcher now want to use natural fiber as reinforcing material, and because want to achieve the sustainable development group. And the problem statement is this granite dust is a type material that abundantly available and unused in the quarry industry. So quarry in Malaysia produce tons of granite dust daily during the manufacturing. So this granite dust is cause the pollution, land pollution, when we dump to the waste, adversely affect the productivity of land due to decreased porosity, water absorption, and also air pollution and water pollution if we don't use this waste. So because the water pollution, and day to day the quarry industry operation produce more and more. So it is crucial to all of us to use this waste to make something profitable. So synthetic fiber are costly and non-biodegradable and mostly not environmentally friendly. So this is the quarry dust under the sand, and because the particles is uneven. And my research objective is one is to develop composite microgranite as a filler in basalt fiber reinforced composite, and secondly to analyze effect of fiber type between natural and synthetic, also the filler. So my method is using research analysis using physical testing for constituent volume fraction, burn-off method, and mechanical testing, impact test, and the morphological test using the scanning electron microscope. And the research methodology, there is composite will be developed. One is unmodified, and also there is 1% and 3% and 5% granite fine powder for the glass, and also the basalt fiber, one unmodified 1%, 3%, 5%. Also the polyester composite, also unmodified 1%, 3%, and 5% granite fine powder. So these three different composite will be developed and also will be testing. So there is more about 420 sample and 420 data for this research. This is the fabrication of the basalt and glass fiber reinforced polymer. You can see that the polyester, this is polyester resin in granite dust. So we measure the weight of the granite fine powder and mix with the polyester, and we stir about 1 hour, and then preparation for the matrix, we cut and we pour the mix of resin and granite dust, and then using the vacuum silicone mold for 1 hour, and then this is will produce this this composite basalt fiber and the composite. We use the vacuum silicone mold is from the company, so that we are more to sustainable, because from using the vacuum bag, we will replace the bag with the others. So between this, we reuse the silicone mold again and again. So this is the material that we produce, the composite. This is the machine that using in the research, the density machine, the analytical analyzer, the hardness, the considerable operation. We use the hot furnace. This is SAM, and then this is impact machine. For the result analysis for the constitutive volume fraction, we can see that in the column for void there is between below 5%. So in typical aerospace grade, below 1%. So for the normal products, it is okay between 3 to 5%. So the newly developed composite, it is suitable and okay for testing and production. For the impact analysis, so for the impact test, this is the machine that we are using, impact instrument, with a mass of 13.24 gram, and the height is 78 millimeter, and the force that we use is 101.3 joule. The sample is 50 mm times 50 mm. So this graph, and then this is the sample, and the result is the effect of granite fine powder on impact properties of basalt fiber and glass fiber. We can see that in this graph, for unmodified, the energy absorbed is 95.13, and when we include the granite fine powder, it will increase to 98.5% until 101.47%, and then it will drop. It also same in the glass fiber reinforced composite, until 3%, 99.79, and then it will drop. And for the impact strength, it also, you can see the trend for the impact strength will increase from unmodified until to 3%, 17.4%, and for the glass fiber is 15.14%. And the impact strength versus maximum value, so we can see that maximum value at 3%. So this is the impact strength for the basalt, 17.4 kilojoule per meter squared, and this is for the glass, and this is for the industrial sample at 4.68. So we can see that the value of the basalt fibre with 3% of GFP is higher than the industrial sample. And based on this figure, the BFRC demonstrate the highest total of 101 and 47, comparing the energy absorbed for the sample. So between in the sample and the BFRC, there is 312% higher specifically, and so you can see that the new develop is greater higher from the industrial sample. So this is the visual damage evaluation of basalt fiber reinforced composite. We can see that all the specimen appear to have a nearly identical damage pattern on the front and back, and we can see the diameter at the bottom. And at the front, we can see the cross and the hole penetrating of the basalt fiber reinforced composite. And this is our damage evaluation of glass fiber reinforced composite. And we can identify also the cross mark and the hole, and we can see the delamination here. And this is the image for sample, industrial sample CTG. We can see the hole pattern in front and the delamination at the back of the CTG. And an award and recognition IPR. This research has been registered to copyright. The reference number here LY2023. This is the invoice or payment from the my IPO, and also have a silver medal at International Research and Information Science Expo, silver medal, and published at Academica Press Solution, Volume 7, Micro GB Truck Body Panel Composite Fiber. And also this is the published article related to the research, the mechanical performance of granite fine dust and this hybrid or nanosilica. Okay. So the conclusion is the effect of granite fine powder on the impact properties of two different composite systems was successfully evaluated. The study used 3 granite percentage, holding 1%, 3%, and 5%, and then we can see that the maximum is 3%, and between basalt fiber and glass fiber, the basalt fiber is highest, and then between the industrial sample and the basalt fiber with granite fine powder is better, about 312%. So the research finding and implication for government policy, encouragement to the industry or researcher to expand the scope of composite hybrid and promote the using natural fiber so it can reduce greenhouse effect and carbon dioxide emission, and then assisting the manufacturing industry like composite, quarry, aeroplane, mould, and others. So on the same time, we support the Sustainable Development Goal in SDG 9, 11, and 12. So that's all for me. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.